Welcome to Spring LIB.
In this problem, you're told that the number of bacteria in the culture is represented by the following function for n of t. So, in part A, what we want to do is find the relative rate of growth of this bacteria. Well, remember, this formula is in our exponential growth model. And so the rate that it's growing at is always going to be the coefficient of our t term. So we'd have 0.25, but we want to change this into a percent. So we move the decimal point 2 places to the right, so it'd be 25%. So that's our growth rate. Now, part B says what's the initial population, meaning when t is 0. So if we found it by substituting a 0 for t, we'd have 915 times e to the 0.25 times 0 power. Well, anything times 0 is 0, so we'd have 915 times e to the 0 power, and anything raised to the 0 power is 1. So we just have 915. So that would be the initial amount. Remember, it's always the number in front. Lastly, what we want to do is we want to figure out how many bacteria there will be when t is equal to 5. So in this case, we're going to substitute in 5 for t. So we're going to have n of 5 equal to 915 times e raised to the 0.25 times 5 power. So in this case, we can go to our calculator. We'll do 915, then our base e, or our constant e, I should say, and for our exponent, we'll have 0.25 times 5. In this case, it doesn't look like you're told what to round to, so I'll just round 2 places after the decimal. So when t is equal to 5, there will be approximately 3,193.66 of the bacteria.